Let's. Hey everyone, this is me again. Welcome to the Space with Linux Special Interest Group update for the ELISA community. Before I get started, I just want to give a huge shout out to Matthew and the aerospace work group. They've been doing phenomenal work supporting aerospace industry, laying the foundations for Space with Linux, and continue to push forward the Space with Linux SIG. So huge kudos to all of you. Before I continue with the updates, let me just give you a quick update on who is this crazy person in front of the screen and what this project is about. If you don't know anything about it, my name is Ramon Roche. I'm the general manager for the Linux Foundation. I've been working with the Linux Foundation for, I would guess, a decade or so. And I've been working in robotics. I like space. I like space a lot. A lot of the challenges that are being solved in space are basically autonomy challenges, which is what we've been solving in Drunkle on Earth, fighting gravity here on Earth, and a lot of those relate. So I'm really passionate and I want to contribute into seeing space, and I want to see some of my commits in space. So that's why I'm here. One of the maintainers for the PX4 Autopilot project. That's why there's a drone in there in my picture. If you want to learn more about that, go to the Drone Code website. All right, enough about that. Let's talk about the SGL. So if you have not heard about SGL, you're part of the ELISA community. Shame on you, but don't worry. Here I am. I'm going to show you what it is. So basically, we're trying to create a Linux distribution for space. What does that even mean? So it's basically open embedded Yocto Linux version that we're going to create with the radiation profile. Why? Because we have to stop reinventing the wheel in space. We need to start reusing more of the software. Open source is great with that. We need to create better collaboration opportunities between space agencies, space companies, vendors, developers, help them create a career path towards open source in aerospace and space. And so basically, everything that open source is great at, we want to put that back into space. Well, not put that back, put it in space. Inspire more confidence in Linux. That's something that it's already well established. So Linux is very well established, but we can do better. We can do a trusted ecosystem. We can demonstrate reliability outside of applications on Earth. And yeah, basically, we want to prepare Linux for whatever's coming in hardware next. Work with hardware manufacturers to make sure that they support the latest and greatest, and that any developers using Linux with the latest hardware has a great experience. Having said that, let me talk to you about what's happened last year and where we're going and what direction we're taking this year. So oh wait, before I do that, this is how a space with Linux looks. This is basically the different layers. We have the hardware targets underneath. We got Microchip, we got AMD, BeagleB Fire, all those stuff in there. And then we got the Yocto Open Embedded build system, BitBake, and then the niceties over there that they provide. And then we created Meta SGL, which is the foundation layer. Safety-aware configuration. We got an MIT license, developer certificate of origin there. And then we have the user space layers, which is what most developers will be interested in. We got Meta Space ROS already in the code base. We do not have Meta CFS or Meta F prime, but that's the goal. And we also want to support custom layers for people doing any type of specific workflows that might not be generic enough to put on the open source repository. So that's basically how it looks. That's basically the goals for the project. Now let's jump into what happened last year. We had quite a busy year. We attended quite a few events. We went to the IEEE SMCIT in Los Angeles. Kate Stewart and myself were there. We hosted the open source workshop, full day workshop for open source projects. We had a lot of technical overview talks for SEL, and then other open source projects like ROS were there. And we had a great time with the space community. We went to the Open Source Summit EU and the Embedded Linux Conference. I gave a talk on Space with Linux there, just introducing the project to everyone. It was one of the first times I did it, and we got very good coverage for that. Then after that, me and Rob Willie went to Singapore for ROSCON, the Robotics Open Source Robotics Conference, and we gave the first I gave a quick demo. Oh, sorry, we gave a quick talk about Spacer Linux, and Rob gave a demo on Spacer Linux in hardware running Space Raw. So that was the first time that Spacer Linux was running on actual hardware, and then also running Space Raw. So that was pretty cool. Open Source Summit Japan last December. I keep thinking it's like last week, but it's already been a few weeks before. A few weeks. So that was a really nice keynote. We had a really nice coverage. Someone called it Paper Moon for some reason that is unknown to me, but I kind of like the name. I hope it sticks. Other relevant events where activities happened from our community, the RISC-V in space, the SmallSat Utah, and the AMD Space Day. I mean, so that community members of Spatial Linux are participating there. Put links in there for those of you that have not read those articles that I mentioned. I hope we share the slides later. So let's talk about the technical direction, what we actually did. So back in January, we had the first commit. We basically put the license, the MIT for the source code, the CC BYSA 4.0 for the documentation. We decided that the developer certificate of origin. We installed the bot in the repo, so it checks for the signed off by check on each commit. And we decided that we were going to target the BeagleB Fire as the prototyping hardware for development, something that's actually been paying off really well for us because it's super easy to, or it's super accessible to get basically. And then on April, we had the first pull request merge. That took a long time to actually did that. But we actually got it. We got the Meta SEL core, which is basically a skeleton layer. We got CAS for layer management. We're based on SparkDrop, the LTS as base for Doctor release. We're not using Pokey. For those of you that are asked, might have that question. We're not using Pokey. We have two distro approach, tiny minimal with systemd based, and plus the systemd based robust one. We want to have a KeyMU plus VOB Fire initial targets. We actually do have those in CI already. In May, after we got the skeleton layer, I set up the continuous integration pipeline. Basically, it's GitHub Actions plus AWS provision servers for running on each request. And we got really nice build times. A cold build takes around 20, 30 minutes, and a warm build that takes like minutes, like 5 minutes at tops, which is pretty good. I set up documentation. We got SBOM generation. We do not have footprint tracking analysis yet, but that's something we want to get into. Let's see. The Red Hat team actually presented the container Spacer Linux in February. So Douglas Langford presented the Podman-based approach to this. That's something that we want to get look more into, is how we're going to actually deploy containers and what type of container infrastructure we need to provide. In July, August, the BIU tracked radiation testing team presented the radiation testing in AMD Versal FPGAs. Basically, the biggest key finding there was that cache ECC helped with processor hangs and which are difficult to diagnose. So the cache ECC helped speed up builds and make sure that it is resilient. But the processor is basically the main pain point for them. That's what they identified. DDR bit flicks corrected with DCC and memory scrubbing. Linux OCM EDAC driver needed patching for actual correction. And then also tested on Linux on TMR soft RISC-V processors. So that was the first radiation research that we presented. And then Aditya, which we actually met at the IEEE SMCIT conference in July in Los Angeles. He's from the University of Luxembourg, he's also doing research on radiation for Linux, but he was also a bit more focused on the boot Linux boot failures under Proton radiation, and he was not using radiation hardened hardware. He was using basically an NXP-IMX 8M module, so commercial off-the-shelf hardware, and he was analyzing the error cascade from early boot, the firmware, device tree to later phases, with ECC not initialized during kernel core phases, and it caused a lot of downstream issues. So he actually laid those out, all of them in research. I actually did not put a link there, but he actually published a paper and all this, which is really interesting. And he, most interestingly, worked on trying to replicate all of these failures on QEMU. And he's agreed to help us try to put some of his work on continuous integration so that we can actually replicate this on pull request changes, which is kind of interesting to us. Afterwards, in October, we talked to John, the rock maintainers, about over-the-air updates. Um, we talked about what the challenges are to actually do software updates over the air, which, if you think about it, there's no air in space, so more challenges there, right? Yeah, so he did a great presentation, presented all the utilities in Rock, and we basically discussed what the challenges would be for us based on the telemetry and bandwidth available there. Oops. And yeah, I just want to highlight this again, the Roscon hardware demo. This is us in Singapore. That's the first board that was running Space ROS. There's a video in there if you want to see that. And there's also a link to his branch that he presented there. But if you go to the MetaSGL repo right now, he already merged all of that into the MetaSGL layer. So it's already even running on CI. One thing that I have not mentioned is that in 2024, we started a formation survey asking the community about the usage of Linux in space and what type of development utilities they wanted to see out of a Linux distribution for space. We have some updated results. I'm not going to present all of them right now, but I just want to focus on this one. So Q4 2024 question was, which of the following distributions are you currently using? And we got Android, Artems, Zephyr, Arch Linux, FreeRTOS, other QNX, Buildroot, Red Hat, Ubuntu, and Yocto. As you can see, Yocto was like the highest, followed by Ubuntu, Red Hat, and Buildroot. How does that change to today? Q1 2026, we got still Yocto King, Ubuntu close second, but the third one did change. We got FreeRTOS and then Buildroot. Let me switch back and forth so you can compare again. So as you can see, there's quite a difference. Now, it did actually cement that grounded the decision of using Yocto. We're happy we went that way. To me, there was no other option, but it was nice to see that the community is actually agreeing with us, and they were already trying to replicate this effort. So that's pretty cool to see. We'll be creating a nice presentation about the formation survey updated results soon. So look forward to me presenting that hopefully next meeting, but I don't know because that's already too soon, but maybe on the one after that. All right, so I'm almost towards the end here. Community and participation. So I want to give a huge thanks to everyone that's been attending all of the meetings month to month. Some of the companies that have been joining from the space industry, we got NASA. Basically, every team at every office at NASA has had someone show up for us. Ames, Goddard, Langley, Marshall Space Flight Center. From JPL, Caltech, and then also other companies, Space Cubic, CCM Astro, Stoke Space, Telepix. From aerospace, Boeing, L3Harris, Going Aerospace, VCLU, Aerospace Exploration Company. We also got Wind River, who's been tremendously helpful with contributing. Red Hat, Sony, Microchip, Orago Technologies, Ampere, Linux, also AMD, not listed here. From academia, BIU, TUIHH, KTH, Technical University of Liberec, CASE, University of Luxembourg. From other open source project, Open Embedded, OpenSDR, Linux Foundation, and TII, and Accenture also contributing. It's been really interesting to see this form. And if you go to the GitHub repo, you'll see that we have more active contributions. We got some pull requests pending, some issues created. I still need to go through my pull request queue and get some of those in, but it's not been quiet. Lately, it's been more active. And if you're thinking of contributing in any project, I encourage you to go there and check out what's happening. But beyond the technical aspect of the project. We actually think that there's enough momentum here to try to spin off this project out of ELISA, out of the ELISA incubation process into its own project. So sit next side to side with ELISA, with Drone Code, and any other Linux Foundation project as its own standalone project. So we think there's enough organizations that are interested in developing a Linux distribution for space and collaborating in this effort. We've been talking to a lot of companies that are interested in this. So the decision was taken to actually form a foundation. So here's the intent. We want to choose the same model as the AGL took, basically reference distribution, not just the spec, with the Jocto-based recipes, not a binary distribution, basically. We want to start with very basic payload-like distributions or solutions for the workflows, but build towards higher assurance levels, eventually get certified and move to the actual flight compute units and drive the actual rockets if we can at some point. Flight software, self-focus initially, ground systems later. Still under discussion, we want to see if we can do Zephyr RTOS integration, see how that looks at, get the HPSC hardware supported with Linux, space with Linux. That's a big one. We have an open thread with Microchip. Hopefully we can get that integrated soon, have a really nice discussion with them. We have not looked into what the security model is. Hopefully that's something that we do soon. But we're looking for companies that are interested in helping support this financially. What we're offering is a seat at the table. We're looking for early founders that help shape the direction of what an AGL project or foundation looks like. Getting us membership early guarantees that you get to help us define what this looks like, how the direction is. Depending on the level you get to, you might get board of directors representation. You can directly influence the technical roadmap. You get a voice in the governance. You get to shape the standard before we ship it. We think the AGL model works because it's an inter-collaboration and it gets you industry buy-in. You get shared investment, shared benefits, and it has already a really nice proven track record. So we're looking to launch this by Q2. We already have open threads with a lot of companies that are interested in doing this. Hopefully we can get it to the finish line. It's a lot of work, I'm not going to lie, but we are really excited to get this formed. All right, so enough of that foundation talk. What's next? Where do we need help? So we got Meta space. So we need help with the user space layers. We get Meta space ROS basically merged in there. So we have support for space ROS. It's already in CI, but we have not looked into what the story is for Meta CFS, for F prime, or for systems like PX4. We need to define what those workflows look like and what sort of integration needs to happen there. And we also need a contributor for those. There already exists meta layers for CFS and F prime, basically. We just need to look into what it looks like in meta SGL and what it makes sense to put in there, basically. We need to look into better hardware expansion. I know we have the Vigo vFire. People want also to support Raspberry Pi, CM4, CM5 type of hardware. Yes, let's do it. We just need someone that's motivated enough to help us get it there. The microchip HPSC plus QEMU, we know that might take a little bit longer. We need basically buy-in from microchip, but we're working on that one. Have a lot of documentation gaps. If you go to the docs, they're pretty much empty. They just tell you how to clone repo, how to do the basic build, and voila, that's all it does. So we need help, maybe a guide on how to port to any hardware while you're contributing the Raspberry Pi CM4 expansion. You also write a guide and say, hey, this is how you would do a new hardware integration. That's something that would really benefit the project. Maybe how to even flash the hardware. Okay, I got the build, but how do I put this build into my hardware? That's another nice build that we can host in our documentation. Some other research areas and some potential groups on the side of the SIG that we need to immediately form right now because there's a lot of momentum. The QEMU fault injection. For CI, we got at least 3 very motivated developers from different research groups that want to help support this. So it's time that we form that group, start those conversations, and start seeing commits. That's one of the things. The other one's footprint optimization, just making sure analysis, and we know what the footprint of SEL is. The S1 generation, I think it's already in there. We definitely just need to make sure that the artifacts are getting published and that it's fully documenting how to get those. All right, I'm basically done. These are the links. If you've been waiting to get the links, here's the links. Mailing list to Discord, website, and both of our GitHubs. MetaSEL for the actual Linux distribution, the SIG for the meeting minutes and anything community-wise for coordination. And if you want to look at the docs, go to sel.elisa.tech. Reach out to me if you have any questions. And that's all for me today. I hope that we have time for Q&A if there's any questions.
Thanks, Ramon. I guess we have actually a few more minutes for questions.
And I cannot see the chat, or maybe I can. Oh, yeah, I can, yes. Oh, thank you, man. Yes, I will be at the Linux Foundation Member Summit. If you're going to be there, make sure you book my meeting and, well, book my session in your calendar so you don't forget it. All right, I guess there's no questions today.
All right.
Well, thank you so much, everyone, and I'll be talking to you soon. Goodbye.